All of you, good morning. My name is Shekar. I am working as assistant professor in TKR College. I deals with the applied physics in the TKR College. So today we'll be discussing about our photodiode. Introduction to photodiode. What is a photodiode first? The photodiode are semiconductor devices that convert light into electrical signals. This is the photodiode is the semiconductor devices made by semiconductor devices. This photodiode is light energy converted to the electrical signals. The mainly this is the technically the modern technically used the number of applications is there. The communication field to the image sensing nature. Next one. Go to next slide. Introduction to completed. And next, photodiode construction and working. How to construct the photodiode? The construction of the photodiode are made up of semiconductors. The made up of semiconductors is two types. One of the intrinsic semiconductors, another one is the extrinsic semiconductors. We made by the two types of the semiconductor constructed the using in the photodiodes. Suppose in the mainly typically silicon or germanium and any p-type or any n-type semiconductors also used in the photodiodes. This light is generated. Suppose the photodiode is the using of the sunlight is hit in the electron hole pair, the generating the electrical current. Working principle. When the light hit or penetrate and hit the photodiode, it generates electron hole pairs. Within the semiconductor materials, these charge carriers are then separated by electrical field, the creating current that can be measured and used in the various applications. Okay. Suppose we see the what is the working, how to working in the picture. Like you see the picture. This is the P-type semiconductor. This is the P-type semiconductor. This one is a P-type semiconductor, and the downside is the N-type semiconductor. N-type semiconductor with the we know that all of you maybe semiconductors is the P-type and N-type is the one part of the extrinsic semiconductors. Okay, P-types having the positive charge nature and N-type semiconductors is the negative charge nature. Okay, so P and N is the combined with the creating junction. This one is the junction. This is the junction. So the junction is having number of electron hole pairs bonding with the electron hole pairs. So the light is hit on the photodiode, penetrate to the P-type semiconductor. The P-type, because of P-type semiconductor is very thin layer. So light is penetrate to the P-type semiconductor and hit to the PN junction diode, the electron hole pair. The electron hole bonding is breaks by using of photon energy. Electrons and holes is the breaks. So pair is created. So holes is moved to the P-type semiconductor side and electrons is moved to the N-type semiconductors side. So the P-type semiconductor is connecting with the anode and N-type semiconductor is connecting with the cathode. So the cathode is attracted to the negative natures, means negative charge carriers, and anode is attracted to the positive charge nature. So this connecting with the external electric field. So the positive is attracted to the positive nature and negative is attracted to the electrons. So voltage is created. So electrons is moving or charge gas is moving. The current sensing is created. Next slide. Go to next slide. Types of the photodiode. This is two types of the photodiode. One is the pin photodiode and second one is the avalanche photodiode. The pin diode is this one also is a general photodiode, but the using of pin means P-type semiconductor and N means N-type semiconductor. I means intrinsic semiconductor. So intrinsic semiconductor sandwich between the P-type semiconductor and N-type semiconductor. So this type is semiconductors is the pin photodiodes. Pin photodiodes. Avalanche photodiode. Avalanche photodiode is the APD using utilize avalanche effect that provides internal again means this one is we discussing about after avalanche photodiode. The avalanche photodiode is the made by p-type semiconductor and I doped with the p-type semiconductor and intrinsic semiconductor and n-type semiconductor and another doped n-type semiconductor doped with the high doped semiconductor of n-type. So the high doped p-type semiconductor is P plus. Okay, this is the pin photodiode and avalanche photodiode. Next one, we'll go to next slide. Advantages and disadvantages of the photodiode. Next, advantages. The photodiodes offer high sensitivity. This is adding the high sensitivity and fast responding time and wide spectral response range, making them suitable for various applications. So this specific applications, uh, specific characteristics, high sensitivity and fast responding time and wide spectral response range. This characteristics gives the suitable various applications. Okay. Disadvantages. Photodiode can be susceptible to noise, gives the noise, and having the limited dynamic range. So this photodiode is using the created some noise, limited noise, and so and required carefully temperature. So this one photodiode using only some limited temperature and some limited uh, dynamic range. Okay, now otherwise is given the noise, created noise. So this one is the disadvantage of the photodiodes. Next slide. Photodiode applications, main applications in the photodiode. Optical communication. First one is the optical communication, using in optical communication and medical imaging and photovoltaics and barcoding scanning. Optical communication. We know the optical communication is using in the geo fibers communication. The number of optical communications is there. The photodiode are used to detect and convert optical signal into electrical signal in the optical fiber communication system. Okay, now this one optical communication is this photodiode is given the electrical optical signal means light signal converted to the electrical signal. This one is used in the optical communications. Medical imaging. Photodiodes are used in various medical imaging techniques. Suppose PET scan aspect scan. If PET scan is using in the cancers, the number of cancer patient is doing the PET scan and aspect scan. So to do detect the measuring radiation, in that measuring radiation and photovoltaics. Photovoltaics are the fundamental building of blocks of solar cell. Suppose the solar cell is having the number of arrays. The array is the number of cells, the solar cells. This solar cell is the created by the photodiode. So this is the fundamental building, the solar cell. Barcoding scanning. Photodiodes are used in the barcode scanning. Suppose in the day mode, any multiplex and any big multiplex showrooms, this and shopping malls, the number of barcoding scannings is there. In the using of the barcoding scanning, a reflecting light, this one photodiode using in the barcoding scanning, using in reflecting of light from barcoding and convert to into digital data. We give the light and taken from the barcoding light. This barcoding is converting to a digital data. This one using the barcoding scanning. Using in barcoding scan. Next slide. Next, pin diode construction and working. We see the pin. This one we earlier we seeing in the photodiode. What is a photodiode? And photodiode is the two types. One is the pin photodiode and avalanche photodiode. The first type is the pin diode construction and working. We see the pin diode. So pin diode, same as this one also photodiode, general photodiode, but extra is the intrinsic layer. This one is intrinsic semiconductor layer is there. So first, how to construct the photodiode? So pin diode. Pin diode is the p-type semiconductor, means intrinsic semiconductor sandwich between the p-type semiconductor and n-type semiconductor. So p-type semiconductor is connecting to the anode and n-type semiconductor is connecting or attached with the cathode. So metal, this one is the metal contract. Metal contract is protected to the sunlight from the sunlight photodiode device. The photodiode device is the protected by the sunlight. So in the between of the metal contact is the protector, and this one is the insulator. Insulator is the goes through the that side of the electric charge carriers. So okay, clear. We see we know the p-type region and n-type region, intrinsic region. And next, go to the next slide. We know that how to working. We see the how to working. Structure and working. This one is the p-type semiconductor. P-type semiconductor, we know that we know the p-type semiconductor is connecting with the anode, n-type semiconductor is connecting with the cathode, and intrinsic region is the sandwich between the n-type semiconductor and p-type semiconductor. So light, sunlight or photon energy or any photon energy is falls on the protector plate or metal plate. This and penetrate to the metal plate and penetrate to the N substance, means N-type semiconductor. Because of N-type semiconductor is used in the thin layer, so easily penetrate to the photon energy, and photon energy is penetrated and in the intrinsic semiconductor having the number of electron hole bondings. The electron hole bonding is energy is absorbs and electron and hole is bonding is breaks and created the electron hole pair. So electron and the created by electron and hole pair is given the one electron and one proton means positive energy. So electrons is attracted by the cathode side and p type sorry, positive energy charge carriers is the attracted by the anode side. So this one anode is the attracted by the negative positives and cathode is the attracted to negative. So we connecting the forward bias, the charge carriers is moving forward direction. So positive negatives is the this one is the negative connecting negative and this is the connecting with the positive direction positive terminals. So positives is the attracted to the this one is the electrons forward bias. So this one is a negative. So electrons is the attracted by the cathode. So cathode is the charge carriers is the moving this side electrons and current is the moving this side direction is this side. Next positives is the moving this side because of anode is attracted to the positives. So positives is the moving this side. So current also direction is this side. So current is sensing is the created by the pin junction pin photodiode. The pin photodiode is the very quickly response because of the I region is having the number of photo electron hole pairs are there in the pin diode because of I region is a very big. So I region is a very big. So number of electron hole pairs also there in the I intrinsic semiconductor. Okay. So this one is the working of the pin diode, pin photodiode. This one is the intrinsic semiconductor. This one is the N-type semiconductor. This one is the P-type semiconductor. So creating the electron hole phase or breaks from the photon using a photon energy and electrons and holes are charge carriers is moving. So current is generated. So applications of the pin diode. Just wait. What is the applications? Okay. Just wait. RF switching and first one is the RF switching means radio frequency switching using in the pin diode is the RF switching and voltage control attenuation. Suppose voltage control means number of refrigerators and a number of uh, electronic devices controlled by voltage controller. The voltage controller used in the pin diodes and switching mode. What is the switching mode? You see that. Next, switching mode power supply. Switching mode power supply is a very quickly response. So in that is the pin diode also used. The RF phase shifting, RF switching using up the pin diode and RF phase shifting. RF means radio frequency phase shifting. Phase shifting is the positive is the negative converted and converted is the negative is the 180 degrees is the phase shifting is there in the pin diode is used. So next slide, avalanche photodiode construction and working. What is the avalanche photodiode and construction? This one is the avalanche photodiode is the mainly the P plus is the I doped with the P type semiconductor. I means is the intrinsic semiconductor and P means P type semiconductor and M plus means N-type semiconductor with the I doped with the N-type semiconductor. So the array of the how to create it. The avalanche photodiode is the I-doped positive p-type semiconductor and intrinsic semiconductor layer and p-type semiconductor layer, and I-doped with the n-type semiconductor layer is the this array of the arrangement of the avalanche photodiode. The P plus means I-doped p-type semiconductor is connecting to the anode side, and N plus means cathode is connecting with the n-type semiconductor side. So the light is or X-rays is the penetrating to the p-type semiconductor, means I-doped p-type semiconductor, and this one is a photon energy is hitted into electron hole pair. See like this in the picture. This one is a electron hole pair is the heated by the photon energy. This photon energy is absorbed by the electron hole pair. The bonding is breaks. So electron is separate and holes is separate. The electrons is attracted by the p-type semiconductor. The p-type semiconductor very quickly and collide with the another electron hole pairs. So see like this, and this electron hole pairs also we creating the, this one is the creating by two charge carriers. One is a positive, another one is a negative. The positive is collide with the another electron hole pair, and negative also collide with the another electron hole pair. This one also two electron hole pairs is the two charge carriers is the collide with the another electron hole pairs. And next one is the, this one also collide with the electron hole pair, and electron hole pair is created, and two charge carriers is the collide with the another two electron hole pairs. So this effect is called a avalanche effect. So this avalanche effect is created number of charge carriers, more number of charge carriers. So this is a very quickly currenting sensitivity. So the avalanche photodiode is a very quickly and very response, the fastly response. So this is the working of the avalanche photodiode and construction of the avalanche photodiode. Next slide. Let's see. Next. Applications of the avalanche photodiode. Avalanche photodiode are highly sensitive photodiode. We know that already. We're discussing about of this sensitive photodetector that find verify application due to the ability to provide internal gain to the avalanche effect. And some keys of application of photodiode, avalanche photodiode. High speed optical communication. First one application is the high speed optical communication. Because of avalanche photodiode are used in receiving high speed fiber optic communications, since and their internal gain allows detecting very low light levels. This is the working as very low light also. This is the using in optical fiber communication systems. And laser based imaging range means avalanche photodiode is employed LiDAR, light detecting of ranging system, and where there's fast response time and high sensitivity enable accurate distance measuring in the 3D. Suppose in the army, the how much the distance using of the laser detector, the avalanche photodiode. This is because of this is the very thick, fast responsive. And medical imaging. Medical imaging. Avalanche photodiode is utilized in the positron emission tomography, means PET. PET scanning is used in the cancers type of patients. So this one also discussing in the photodiode applications. And astronomy and astrophysics. The astronomy and astrophysics is using of the galaxy and telescopes using in the this APD is the using in the telescope astronomy instruments. This instruments is using in the distance galaxy to see the galaxies and exoplanets. So this one is the avalanche photodiode applications and spectral response and photodiode selection consideration. Why to consideration of the photodiodes? Because of this is the spectral response and sensitivity and gain and speed of bandwidth. The spectral responsibility is equal to the uh, light rays waves. So the spectral wavelength is this spectral wavelength and light wavelength is both are near. So this is the using of consideration and sensitivity and gain. The sensitivity and gain is the also very sensitivity and gains the number of charge carriers. And speed of bandwidth. The speed and bandwidth is the equal to the light rays. Yeah, we're using in the appropriate the bandwidth meet with the required because of photodiode speed and bandwidth nearby the light rays. So this is the consideration of the photodiode sections. So this is the end of the class. We see another class. Okay, this is the photodiode overall discussion and pin diode and avalanche diode. What is the working and construction and application? This is the photodiode overall data. Okay, thank you. All of you. Switch.